So let's start with number one. First thing to do is to number them, right? To stay organized. So we're going to go calling this one 1, 2, 3. And we need to decide which variable we're going to cancel. So you guys tell me, what do you want to cancel? X's, Y's, or Z's? Which one looks the easiest to cancel? The Y's. Look at those. There's not even any number on the Y's. So I could cancel out Y's by simply combining my first one with my second one, yeah? I mean, you could decide to cancel out Z's, you're going to get the same answer. Or you could cancel out X's, you're going to get the same answer. But if I use 1 and 2, so 1 I'm going to rewrite it. It's going to be 2x minus y plus 2z equals 15. Let's rewrite number 2. That's negative x plus y plus z equals 3. So what I'm doing here with the notes of 1 and 2 is I'm showing that I'm combining my first equation with my second equation. When I combine them, the y's do cancel. I end up with a nice, beautiful 1x plus 3z equals 18. And ladies and gentlemen, this was step 1 from yesterday's notes. This is what we call new equation number 1, NE1. So step 2 was to go back to the original and use the one we have not used. Which one have we not used? Number 3. We haven't used number 3. And the most important part of step 2 on yesterday's notes was to get the same variable to cancel. Okay, so we need to use 3 for sure. So let me go over here and make a little bit of space. So I'm going to use 3. I'm just going to rewrite it right here. 3x minus y plus 2z equals 18. Okay, so there's my third equation, and I want to combine it with which other one to get the same variable to cancel? 1 or 2? 2, that's right. So let's combine it with 2, and we're not even going to change 2. This one's really easy. You don't have to change anything. So let's just rewrite it. It's going to be a negative x plus y plus z equals 3. And now we're able to combine and cancel, or combine and eliminate the y's. So what's our new equation? It's going to be what?
Negative 2x.
2x plus 3z equals 21. And this is what we call new equation number 2, NE2. Now, why do we box them in, and why do we call it new equation number 1, new equation number 2? Because we're going to take both of these equations, we're going to take both of these guys and put them together as a 2-by-2 system. Now, that's why it's so important that the y's canceled on my first step and the y's canceled on my second step. That way, when I get this new 2-by-2, it's only with x's and z's, right? So let's rewrite it. I want to pause it and rewrite it to save some time. Go ahead and do that. So here's our new 2-by-2 system. I simply took new equation 1 and wrote it up on top, new equation 2, wrote it on the bottom. Now we could actually solve this 2-by-2 system. We could ignore everything else and just focus in on the 2-by-2 system and think, how am I? So what's the quicker path? Canceling out x's or z's? I would say z's, right? All you have to do is what? Multiply one of them by negative 1. I want to multiply the top one by negative 1. I want to put in parentheses, put a negative 1 out here. And I'm going to write my new equation right to the side of it right here. And that's going to be a negative x. It's going to be a negative 3z. And it's going to be a negative 18. And the bottom one, I'm going to leave it exactly the same. I'm just going to rewrite it. 2x plus 3z equals 21. And of course, now we're able to combine. I usually write this in blue. The negative x and the 2x, what do you have left? 1x. The z's cancel, equals what? 3. So we don't even have to solve this blue equation. It's actually already solved. It's just x equals 3. So if you have an answer x equals 3 on a 2-by-2, how do you find the other answer? By plugging it into your 2-by-2. So I'm going to take that value of 3 for x and plug it into the 2-by-2. I guess I'm going to go with so I'm looking at this x right here, but then I'm looking at this x up here on the original 2x2, the red. I want to take this 3 and plug it in for x up here. So instead of x, it's going to say 3, and then you have the plus the 3z equals 18. Okay, once again, I plugged it into this top equation of the new 2x2 system that I came up with. And now I could actually solve it by subtracting 3 on both sides, subtracting 3. I'll have 3z equals 15, which means that z, when you divide by 3, z equals what? Z equals 5. Alright, so we have 2 answers, but it was a 3x3 system. We need a third answer. We're missing the y value. So what we need to do now, since we have 2 variables, 2 answers, we could go back to the original. Okay, x was 3, z was 5. Let me jot this down up here. X was 3 and z is 5. So I'm going to pick one of my original 3 to solve for y. So which one would you guys like to pick? Number 2 looks pretty easy, yeah? Let's plug it into number 2. I mean, they're all easy. Doesn't matter which one you pick, actually, but I want to go with number 2. So we're plugging in negative x. That will be negative 3. Plus y. We don't know what y is, so we keep it plus y. And then plus z, that's a plus 5, equals 3. Is everybody with me? Okay. So now let's combine like terms. The negative 3 and the positive 5, they're on the same side of the equation. I could just combine these in my mind and rewrite my equation. So my equation is going to be y plus 2, because negative 3 plus 5 is positive 2, equals 3, which means that my final answer for y, if I subtract 2 on both sides, will be y equals 1. So ladies and gentlemen, to write our answer for number 1 as an ordered triple, which you should, you're going to write parentheses, and they have to be in order x, y, z. So you have 3, comma, 1, comma, 5. Moving on to number 2, a lot of people get freaked out with number 2. Why is that? Because the third equation is not even a 3-variable equation. You could solve it, right? So how about this? Let's actually focus in on that third equation and actually solve it. Let's just divide by 4, divide by 4. So ladies and gentlemen, we know an answer already. Z equals negative 4. That is an answer. I'm going to box it in, and I'm going to use it to my advantage. So what do we really have here? We have 2 equations that have 3 variables. I need to combine these 2 equations to get a variable to cancel. Now, would it be smart to cancel the 3 z's, this one and this one? It would not be smart, and I'll tell you why. Because you're going to have an equation that has an x and a y in it, but you want the z to be in it. Why do you want the z to be in it? Because you already know what z is. Does that make sense? So instead of, I mean, this, everybody sees, oh, positive 3z, negative 3z, I want to cancel out z's. Don't do that. I mean, you could technically, but you already know what z is. As a matter of fact, how about this? How about this? As a matter of fact, let's take the value of negative 4, and let's take that negative 4 and put it right in here and in here. And what's that going to do for us? It's going to create a 2x2 system right from the start. I almost didn't notice that. So you take that z value, plug it right in, you get a 2x2 system right from the start. Ladies and gentlemen, if I plug in the z being negative 4 on the top equation, I will have x minus 4y plus 3 times negative 4 equals negative 27. And then the bottom equation, the second equation, will be 2x plus 2y minus 3 times z, we said that's negative 4, equals 22. So we could simplify each of these and then move the numbers to the right side and have a 2x2 system. So right here I have a 3 times negative 4, that's negative 12. And if I wanted to get rid of the negative 12, what would I do? If I wanted to get rid of a negative 12? Anybody? Out loud so the recording could hear you. Positive 12. So we're going to go positive 12 here, positive 12 over here. So what's negative 27 plus 12? Negative 27 plus 12? 15. Yeah. So negative 15. And I'm kind of doing work in my mind here. I'm not showing my work. What I did was, this was a negative 12, so I had to add 12. If you add 12 to negative 27, you get a negative 15. So this is my new top equation over again. Let me put a line right here just to separate that one from this new one. Now the bottom one, this gives me a positive 12 right here, right? And if I go, how do I get rid of a positive 12? By subtracting 12, and I'm going to subtract 12 over here, and what will I have on that right side? And I have 10. So let me rewrite my bottom equation now. That'll be a 2x plus 2y, and we have that equals 10. I hope we all understand what I did here. This is our new 2x2 system that's ready to be solved. Yay? So this one was super easy because we had an equation that we could get an answer to immediately. Now let's solve this thing. How do we solve this? What do we do? Want to cancel out x's or y's? Y's, okay. Multiply the bottom equation by 2. So the top one we're going to leave the same. Let me rewrite it over here. X minus 4y equals negative 15. The bottom one we're going to multiply by 2. It's going to become 4x. It's going to become plus 4y. It's going to become 20. And now we're able to combine the lines, the y's. And when we combine, we get the 5x. We get equals, we get positive 5. Because negative 15 plus 20 is 5. So x equals 1. X equals 1. I want to take this one and plug it into any equation I want. I want to go with the bottom one this time. I want to go plug it in right there. It's going to say 2 times 1 plus 2y equals 10. So this is really just 2. I'm going to subtract 2. I'm getting lazy here on my steps. Subtract 2 on both sides. I'll have 2y equals 8, which means that my final answer, y, is going to equal 4. Somebody say 2? 8 divided by 2 is 4. Okay, so for my third answer, all I need to do is take that 1 and 4 and plug it back into any equation on the original. X is 1, y is 4. Oh, we already have z. Yeah, so we're done. Let's just write it as an ordered triple. Parentheses, 1, comma, 4, comma, and we originally had negative 4 as z.